The Unreal Engine reflection system is a very complicated tool, but it encapsulates all of your C++ code in such a way that you can expose pieces of it to the engine/editor as needed. Now with that, there are some drawbacks and there are some issues that we're going to need to account for. But we're going to talk through them here as we go and take a look at what the reflection system truly is and what it means for you and your code. Now we're taking a look here at Unreal Garden. This is a community-driven site that originally was started by Ben UI. He's a great, excellent content creator who took a step back to allow this to sort of flourish as a community-driven place. And it's definitely my go-to anytime I have any confusion or anything that I need to learn more about Unreal Engine 4. It's just very well documented and it's very easy to use. It's very pleasing to the eye. And generally, I find that it tends to be a bit more accurate than the actual documentation, to be honest. With that, we're going to take a look at a bit of stuff here because basically when we get down to the nitty gritty, these elements here make up most of the basics of the reflection system. That is U properties, U functions, U classes, U structs, U interfaces, U enums, and U meta, and U params. So at the end of the day, when you are creating C++ code, what you are in fact doing is writing C++, and the only way it actually gets into the engine is by reflecting it into the engine. Now with that, there are some caveats. There are things that cannot be reflected into the engine. For example, instead of using a const char or something to that effect, you need to instead use the f string or f text, something to that effect that is more Unreal Engine friendly. Now the reason for that is because when you are reflecting these different variables into the actual engine or editor, you're basically telling it, here's what this is, here's how to use this, and certain concepts don't always translate well visually when it comes to things like const chars. Const char, it doesn't quite fill the same niche or role as something like a string or an f text. Not to say you couldn't, but for the most part, Unreal Engine prefers to work with those things. Now let's go ahead and take a look. There are a lot of different elements to these, but the main thing you want to look at when you're looking at these is sort of the idea of U properties are specific to variables. So you basically have specifiers, which are these things down here, that allow you to customize your variables in ways as needed, whether that's including them in asset bundles, having generated defaults, blueprint read only things. There's a lot of different parts and pieces that you can access here. So the nice thing is, if you're ever looking for something, a specifier or something that you want to access, you can definitely look here and I'm sure that you'll be able to find that. But for the most part, there is a lot of different options. Now, the ones we're going to worry about today, because while the U properties are really important, I think they're not nearly as important as the U functions. There is a few specifiers here that are sort of the key ones, the ones we're going to use quite a lot. So you have things like compact node titles. These allow you to create, as you can see here, succinct titles. For example, kind of how like we have multiply, add, minus, things like that. That's basically a compact node title. We also have things like tooltips, which we'll walk through how to add a tooltip. And there's an awful lot of options, as you can see here. Now, not nearly as many as U properties, but I feel like these are a lot more frequently used and a lot more important ones. And then, of course, there's always the U class and things like that. But let's actually go ahead and use some of these specifiers and talk about the reflection system a little further inside of our actual code. So if we go in here into our C++, we're going to create a function here using a lot of these specifiers to allow us to create a function that is going to get us our app version. So I've got my code that I've originally written for my own game up here on the right, just so I can make sure I'm telling you accurate information. But what we're going to do is we're going to create a U function. Now this is a macro in and of itself that just tells Unreal Engine, hey, what you're about to see is a function. And this needs to be able to be run in the engine. Now, one of the downsides of using a U function to reflect your function over to Unreal Engine is that you cannot have function overloads. I don't know if they're going to come eventually or if they'll come ever at all. But if you are unfamiliar, for those of you who are blueprinters or maybe less experienced coders, inside of most C++ code, people do something called function overloading. It's the idea that you can have a function called A and maybe have 3 different versions that take different inputs and do different things. So for example, you could have A that takes an input of A and B. You could have A that takes an input of C and an A that takes an input of A, B, and C, and then do something different on each one of those. With Unreal Engine, when you reflect a function, it needs to be the sole and unique name for that function. Now, part of that is because if you have 3 functions all named identically, it's a little hard to differentiate those in Engine. Now, my hope would be that someday they would have that, but then maybe have a way to hover over it and see the different inputs or something like that. But I can also see why they would want you to not have to like dig through that, or worse, maybe you'd only see one, you'd click on it and then have to select which function you want to use or something to that effect. Instead, they take the route of you need to just create one function or create different functions depending on what you need. So for this function, we're going to give it some specifiers. So first, we're going to call this blueprint pure. Now you have a couple options here. You can call it, you got blueprint authority only. This is for networking and things like that. You got blueprint callable, which is your standard executed function. You have blueprint cosmetic, blueprint implementable event, blueprint native event, and then blueprint pure. What we're going to be doing is a blueprint pure. The reason for this is blueprint callable and blueprint pure work slightly differently. Now, that's not to say you can't technically use pure as a blueprint callable function, but generally the best practice is getters should be a blueprint pure, because then you're not plugging anything in. You're just saying, here, give me this information, I'm going to put it in. Versus things that are needing to actually make changes or do something should be a blueprint callable event. So for this, we're just going to call this blueprint pure, and we're going to add some meta tags. Now, meta tags, basically, you put them in the parentheses here, and you can put a few different things depending on what you actually need. So you can give it things like display names. You can give it, what we're going to give it is a tooltip. And so first, let's start with a display name, because of course we want to give it some kind of blueprint node name. Technically, I believe by default, if you don't give it a name, it will actually give it the name that you give the function. But what that means is if you don't have spaces in your function, I believe it won't add those spaces, or it might if they're capitalized. I think there's a lot of different weird rules around it. This lets you be a little bit more specific on what you want the name to be. So as an example here, we'll just say get, we'll just call it get version, because what we're going to do is we're going to get the version of our project. Now, by default, all Unreal Engine projects start out at version 1.0.0.0. But you can always go ahead and change it, as I've done in our project, just so we can see the different version number. Now we've got our display name, but let's also go ahead and give it a tooltip. Now, one handy trick is sometimes if you're not sure if you're in the meta parentheses or not, if you've got a whole bunch, you got a really long line with a whole bunch of stuff in there, just make sure it's showing up in your prefill here and telling you what you can enter, because if you don't see that, you're probably in the wrong place. So for the tooltip here, we'll just say gets the current projects version. And then let's go ahead and we're going to add one more thing, and that is going to be our category. Now, the cool thing with categories are that you can add what's known as a pipe. And that's basically a vertical line, and that'll allow you to separate the category and create deeper level categories to separate your different functions. So as an example here, we're going to say this is a helper function, and we're going to separate it by pipe, and we're going to call this a UI. And we won't call it UI helper function. It'll just be helper function, and this is in the UI category under helper functions, because this is something we could display on our UI to tell the players what version they're playing. Now with that, we're going to go ahead and actually create what function we want, which is going to be a static f text. Now you technically can do a string here, but we're going to do an f text specifically because when you are setting text on your UI HUD, a lot of times it requests text. Now we can also have, I'm going to show you how we can also convert string into text, so that way we can use it other places. So let's see here, and we're just going to call this get version. All right. And let's go ahead and right click it, and we're going to do quick actions and create definition. As you can see by default, it's going to return some f text, but we're going to want to be doing something a little bit differently here. Now, what I'm going to do is, so that we can convert this into a, so that we can have both a string version and a text version, what we're going to go ahead and do is create an f string. And we're going to call this temp version. And then from here, this is where we actually need to get into the engine and access our configures. Sorry, we need to access our config. So we're going to do gconfig, and then we're going to reach in and we're going to be looking at our members on the gconfig, and specifically we want to look for the get string. So what this is going to do is this is basically going to go, hey, inside of our configuration, we're looking for something. We're looking for a string. Here is where that string is at. And so what we're going to do is we're going to pass in a text, and this text is the actual address or location of what we're looking for, which is specifically going to be script / engine. I'm looking over here just to make sure I'm typing this out correctly. Settings.general project settings. And these all need to be capitalized identically, because if you don't have it capitalized in the same way as I have it here, it won't be looking in the same place, because specifically it's looking for the file with those capitalizations. From here, we're going to add a comma. We're going to move on to a new line. In fact, I may actually go back here and put this on a new line just so it's a little easier to read. And next, what we're going to tell it is within that file, because we've gone ahead and gotten a file, we need to find specifically the project version. So we need to say, here, look for this text. So it's going to go in and it's going to look for where is the project version. So it's going to go find it. Once it captures that project version, that is when it's going to return the string. But it needs somewhere to return that string to. So we're going to return it to the temp version. And so by doing that, we're telling it set the temp version equal to what you found. Now you need to pass in our game INI, because specifically this is our, I believe, part of the get string. It's the specific file name. So it's going in and it's saying the section. So that's specifically, it's saying, hey, in the project settings section, look inside of the game INI file and look for the project version string. And that's going to return here to the temp version. And then from here, we'll go ahead and do that. Now we've got our string, right? And this is something we're probably going to want to return as a way to get back a unaltered version. Because there may be times when you're doing translations or different language versions. And while our version number isn't going to be something that you really are going to be setting a different version. I mean, there may be some times when you're setting it in non-Arabic numerals, but for the most part, most languages are going to use the same numerals. But just as an example, I'm going to show you how you would return that if you were going to return it. So let's say we're going to return it. We're going to speak specifically on the reflection system. There's a way to take in a variable and a way to return a variable. So we're going to do both here. And I'm also going to show you how to set a default. So let's say as an example, right, we're going to have a prefix and this is going to be of type F string. And what this is going to be is this is going to be something we're going to set before our version. Now, by default, we're going to probably want this prefix to have some default setting. So we're going to set this to version, and we'll leave a spacing to make sure there's a space between this and the version number. So we'll say it's ver space, then version number. Then from here, we're going to want to get that back, that string, right? So let's say we want to actually return a string here. What we're going to need to do instead of doing an F string like we did before, we need to do F string ampersand. So for blueprinters who aren't necessarily that familiar with coding, the ampersand just means the address. So where is this thing actually being stored? So when we tell the reflection system, hey, here's the address of this thing, what it's saying to it is basically, here's something I'm going to give you rather than you're going to give me. When you leave it like this, you're basically telling it, hey, I want to take something in. Here's the default. So if they don't fill in anything, this is just what I want back. And it'll also be shown inside of the box once we compile the engine. So to send the F string, we're going to say this is the what do we want to call this? So this is the return string, and return value is going to be what's set for the text. So we're just going to say return string. All right, now we're going to copy and paste this over, but of course we're going to need to remove specifically the default here, because you don't need to include the default once you have it at the actual definition, because then you're redefining the default. That doesn't necessarily make sense. So from here, we're going to go down and first we need to actually get that return string back to the node. So what we're going to do is we're going to say return string is equal to our temp version, now that it's got the actual version number. But what we're also going to do is we're going to actually add that prefix here. So we can actually say, hey, let's go ahead and add our prefix. Now, of course, you don't necessarily have to do this, but I'm doing this as a way to just show how to input and output from this function. Now, of course, we did do it as a blueprint pure. What I would normally do here is make this a blueprint callable. In fact, I might do that now, but technically you can leave this as a blueprint pure. You know what? No, we're going to go back. No, we're going to leave it as blueprint pure. I'm going to show you all what that looks like. Just because blueprint callable is very obvious as to what that looks like. From here, now we're going to go ahead and we need to actually get our string. You know, let's say we want to take our return string and pass it in so that we can actually pass it back. But as a text, something cool we can do here is actually go return string. And we're going to set it equal to return, is it f text? And then what we want to do is inside of the f text, there is a basically a way to convert this to string from string. You can format it, you can get empty from name. What we want to do is we want to go from string. So we're converting to an f text from string, but specifically the string we're going to want to send is, this shouldn't be return string. This needs to be return text, not return string. And it needs to be of type f text. But what we're going to do is we're going to actually get the return string, which is basically this prefix temp version, which I prefer to do that directly rather than trying to access this thing that we're trying to return back there. But this from string is going to take these two that are stringed together, and it's going to return it as an f text. And then what we need to do is just return this in the place of this empty f text. But all right. So now we've got our function built and we've got everything ready to go. Let's go ahead and take a look at what that looks like now that the reflection system can see this function. So as you can see here, we got an error. Specifically, this is one due to the fact that we have a parameter in the first slot instead of in the second. Now this was not completely intentional, but it's a good learning moment. Sometimes I kind of forget about it. But essentially, if you want to have defaults, anything that is going to be default needs to be after anything that is not default. So for example, here, since this is something that we're returning, this f string, that needs to be the first item in the list. But for our default there, our prefix, that technically needs to be second. But there we go. So now if we go ahead and rebuild, we should see that correctly build this time. All right, so now we're actually in Engine. It's finished building. What we can see here is I've just removed the previous episode, the little bit down there. And what we're going to actually go ahead and do is go find our function. Now, what you can do is you can always, of course, go manually look for it, and you should be able to find it under specifically that category of, what did we give it? It was the helper function. That's right. So we can always go find it under the H for helper function UI, or you can of course search for get version. And if you hover over it, as you can see here, we add that tooltip, gets the current project's version. Now, as you can see, we're taking in the version of the project as the prefix to the actual string or text here. So it'll include version space. And then we're returning two different things. We're returning the pure string, and then we're returning the actual text value. So let's actually go ahead and first, so now we can go in and see it. Yep, it's correctly showing 0.0.1.555, which is what I set it to in the project settings. So if we go ahead and, of course, we're going to get the errors because this is a project template that's way out of date. Now let's go ahead and take a look at the string. Now, if everything's been done correctly, we should see the string, but the benefit we have here by keeping the string is if you ever want to do any kind of translation. So let's say instead of the version as you prefix here, you could have that be language specific. Now that's of course assuming you're going to use it in this way. I think for the most part, you probably want to have this be some kind of string table and switch based on the language, just for the localization. Because you have like I believe in the localization dashboard, you can have like all of those connected to different languages. But yeah, let's go ahead and just make sure that the string is working as expected. And yep, of course, it is also working as expected. But yeah. So that is the sort of basics of the reflection system and how it works. It is still kind of a complicated system, so I understand if it doesn't all make sense initially, but just the best way you can think about it is you have C++ code that you can run independent of the engine. You can do whatever you need to do, but then anything you want to be able to use as a blueprint node in blueprints some way, or be reflected to blueprints, for example, variables, need to be as part of the reflection system. So as an example, just real briefly before we go, if you have any functions, they need to have the U property specifier. Of course, whoops, it would help if I have that. So if you wanted a float to be health, that U property bit is what tells the engine, hey, this is a float. Oh yeah, that's right. It needs to be float lowercase. So yeah, that's pretty much everything there is to the reflection system. If you have any questions, leave them below. If you ever want to know what specifiers you can use, you can definitely go take a look here. I'll link it down in the description. I don't remember if I mentioned that earlier or not, but otherwise, make sure to leave a like, comment if you have any questions or suggestions for video ideas, and make sure to definitely subscribe. If you haven't already, we also have a membership. I've added some emojis, and there are some benefits to being a member. Not yet, but the plan is over the summer, I plan to get ahead on videos. That way members can actually watch them ahead of time. But we will never gatekeep any content necessarily. It's just more if members are going to get it early. I think that's the best way to handle it. I've got a few members already, so as always, thank you guys so much for supporting me. It definitely means a lot knowing that you guys really truly support what I'm doing here. But yeah, I think that's pretty much everything. So good luck and good hunting.